In this video, we're going to learn how to solve side-side angle triangles using the law of sines. Now again, I wrote the law of sines here in the top left for easy reference as we solve these problems. Now, side-side angle is not one of the congruent triangle cases. It's actually referred to as the ambiguous case because it doesn't always mean there's one unique triangle for the information you're given. It's actually very conditional on how you get the height of that triangle and what that is, depending on those two sides and the angle. So for these four situations we could run into, let's say we're giving side A, side B, and angle A. And I've conveniently left off side A because that is the point of the triangle. That is the part of the triangle that's usually up for contention. So first, A has the potential to be less than the height of the triangle, which is usually found by doing opposite over hypotenuse. Sine of A is equal to h over b, and just multiplying by b to get b times sine A is equal to h. That's why we don't have A as a part of that height. But let's say that value for A was less than the height. Well, if I try to draw that, I can go straight down to try to reach the other side. But if A is smaller than the height, then there's no way for me to get a triangle, and therefore we say this is a no triangle case. Now let's say that the height A is exactly the same as the height for side A. Well, then I have to go straight down to try to reach it, but by doing so it's going to create a right angle for the triangle, but you do have one triangle that works. And lastly, let's say that A is bigger than the height, but still less than side B. Then that means that I can make a triangle, because if I go straight down, I would go past that point, so I have to kind of angle it off to the side. So there's side A, so there's one triangle, but if I were to swing the same length over to this side, there's a second possible triangle I can get as well on this side. So depending, I could have two possible triangles. That's why this is often referred to as the ambiguous case, because sometimes there could have been two choices. And lastly, if side A is bigger than B, there's no room to swing it back this way. So it would just be the one triangle that comes outwards. In this case, probably the biggest side of the triangle. So just one triangle. If A is bigger than B, in that case, you don't have to worry about the height at all. Now, let's look at a few situations. Let's solve each of these triangles around answers to the nearest hundredth. Now, I will not be referring to these cases until after I go through solving, because I want to show you what it looks like just to go about solving this normally, and then what situations you can run into, and then I'm going to explain why we're getting that particular type of situation. So let's say we have side A is 2, side C is 1, and C is 50 degrees. So I'm going to label my triangle. This will be angle A, angle B, and I'm looking for both of those, and I'm given angle C. So I want to find these two angles, but I'm only given 50 degrees for C. And then I'm given side A, which is 2, and side C, which is 1, but I'll be looking for side B. So this is what I'm looking for, these two angles on that side to solve the triangle. But I'm given a pair of angle C and side C, so I can use the law of sines to try to figure that out. So I have sine of C over C is equal to sine of A over A. So sine of C would be 50 degrees over side C, which is 1, is equal to sine of capital A over side A, which is 2. And then I'll cross multiply to solve, giving me sine of A is equal to 2 sine of 50 degrees. So I'll figure out what sine of, or 2 sine of 50 degrees is. And again, double check that your calculator is in degree mode before you go, because I am using degrees. And I get 1.532. So I'll have sine of A is equal to 1.532. But this is impossible to happen since sine's max value is 1. You won't get a solution. And if you try to finish solving this by taking the sine inverse of 1.532, your calculator will remind you why this is impossible. So sine inverse of 1.532, domain error, meaning there is no possible way to plug that in. So in this case, we say there is no solution or no triangle that exists. Now let's look at another situation. A is equal to 3, B is equal to 2, and angle A is equal to 40 degrees. So I know angle A, which is 40 degrees. I know side A, which is 3, but I don't know angle B or angle C, but I do have side B, which is 2, but I'm looking for side C. So again, I'm giving sine of A over A, so I'm going to use that to help me find out what angle B is. So I have sine of A over A is equal to sine of B over B. So that's sine of 40 degrees over 3 is equal to sine of B over 2. So cross multiply, I get 3 sine of B is equal to 2 sine of 40 degrees. Then I can divide by 3, so sine of B equals 2 sine of 40 degrees all over 3, which when I plug that in, 2 sine of 40 degrees divided by 3 gives me 0.42, which is definitely a possible value for sine. So I'll take the sine inverse of that value, and I'll get that angle B is 25.37 degrees. And again, rounded to the nearest hundredth, following the directions here. So now brings up the question, could there be two triangles? Now the reason why we might get two triangles is that step right here. Whenever you take the sine, you took the sine inverse. I'm going to put second angle with a question mark. Whenever you took the sine inverse of 0.428, I'll even say 5, sine is positive in the first and the second quadrant. The inverse function will only give you the angle in the first quadrant. So the other possible sine value could be, and I'll call this B2, other possible angle would be 180 minus 25.37 to find the angle that's in the second quadrant, which gives me B2 to be 180 minus that angle, 154.63. Now, the reason why I'm checking to see if I could use this possible second angle, because it could be two different triangles. That angle I'm getting up here could either be a bigger angle or a more acute angle, or both are possible. So I'm going to check if I use this angle of 154.63, I still have to use the 40 degrees with A. And if I were to add 40 degrees to that angle, I get something that's over 180. So that's why I know this angle cannot work. Now, the reason why I know I'm now getting just one triangle is now that side that's opposite of the angle is actually bigger than the other side. A is bigger than B because 3 is greater than 2, means I should only have one triangle. But even when I check here with that sine inverse situation, Even this couldn't work, so I know I'm only left with angle B. That could be 25.37. Now that I know that that angle is 25.37 degrees, I can use the fact that all the angles add up to 180 degrees to find angle C. So 40 plus 25.37, and subtract that from 180, gives me that C should be 114.63 degrees. Now I'll write that up top here. C should equal 180 minus 40 degrees minus 25.37 degrees, giving me C is equal to 114.63 degrees. And now that you have angle C, you can use, again, sine of A over A equal to sine of C over C to finish solving. So again, we have sine of 40 degrees over 3 is equal to sine of 114.63 degrees over side C, which is what I'm looking for. I can cross multiply, give me C sine of 40 is equal to 3 sine of 114.63 degrees. Divide by sine of 40, C is equal to 3 sine of 114.63 degrees all over sine of 40 degrees. So C must equal, plug this in, 3 sine of 114.63 divided by sine of 40. C must equal 4.24. So now, just to double check my answer, my smallest side is B, which is 2, and that is my smallest angle of the 3 angles. We write that in. And side C, which is 4.24. And then my biggest side is side C with 4.24, and that's across from my biggest angle. So a nice little check to make sure that our answer makes sense. Now the last example I want to go over is, again, when A is less than B, but it's also greater than the height you would normally get. So here's a situation where we can come across 2 triangles. So again, I'm going to label everything I know. So I know angle A, side B, but I do not know angle B, angle C, or side C. So I'm going to split my work in 2 parts. First, I'm going to find out what angle B is. So again, sine of A over A is equal to sine of B over B. So sine of 35 degrees over 6 is equal to sine of B over 8. Solving for sine of B, I can get sine of B is equal to 8 sine of 35 degrees over 6, which, plugging that in, I can get 8 sine of 35 divided by 6. Sine of B will give me equals 0.76. I'll even put 765 to be a little more accurate. And then I'm going to take the sine inverse of that. So B is equal to sine inverse of that number. And it gives me B is equal to 49.886. So I'll put 49.89 degrees. So that's one possible triangle. I used clouds for my first triangle, but my second possible angle for B would be the supplement of this angle. So 180 minus that angle. So 180 minus 49.89 degrees, which would be 130.11 degrees. Now the reason why this angle is possible is because 130.11 plus that 35-degree angle is still less than 180. So I have two possible angle C's as well. So there are my two possible angle B's. Now my two possible angle C's, I'll put C2 on this side, which would be 180 minus 35 degrees minus 130.11 degrees. And that gives me 180 minus 35 minus 130.11, 14.89 degrees. And for my first triangle I found, C1, that angle would be equal to 180 minus 35 degrees minus 49.89 degrees. Let me put that back in the light. (95.11 degrees). So C1 is equal to 95.11 degrees. Again, using little clouds for my first triangle and boxes for my second one. And now I'm going to find side C following that angle. And again, I'm going to use sine of A over A for both of these, just because that was the information given to me. And I'm going to set that equal to sine of C over C. So I have sine of 35 degrees over 6 is equal to sine of, for my first triangle, 95.11 degrees over C. Cross multiply and getting C by itself, you find that C is equal to 6 sine of 95.11 degrees all over sine of 35 degrees. And plugging that in, we'll get 6 times sine of 95.11 divided by sine of 35. Gives me C for the first triangle. I should put these C1s in here to label everything. 10 is equal to 10.42. Again, let me also box off that work from up top too. 10.42. But for my other version of the triangle, I get that sine of A, which is 35 degrees over 6, is equal to sine of, now I'm using 14.89 degrees over side C, which is the second triangle. So let me label all that C2. C2 will equal 6 times sine of 14.89 degrees all over sine of 35 degrees. Leave me with this side C2 equal to 6 times sine of 14.89 divided by the sine of 35 degrees. 2.69. So two possible solutions for two different triangles. And again, just to double check that they both work, use my bubbled answers. The biggest side is the C side, and 95 degrees would be the biggest angle across all the angles. And the small side was A side, which is the smallest angle of all the angles. And if I did it for the other triangle, the biggest angle is angle B in this case. And side B would definitely be the biggest in comparison to 6 and 2.69. And obviously 2.69 is the smallest side. And angle C for the second triangle would be the smallest angle. So it does, in fact, work as a solution. So my little bit of advice for when solving side-side angle triangles is to always check your sine inverse. Make sure that the other possible angle that could work for it is not a possible solution. And after you check that, you can go about solving it however you like. And that is how you solve side-side angle triangles using the law of sines.